Hi, this is Dan Bullard, retired electronics engineer, sitting on the front deck of my houseboat again. It's lovely. It's a nice sunny day, and it's not cold enough. I don't have to use my heater, so you don't have to worry about that. And I'm down to just my regular shirt. I'm here to talk about harmonics again. I love the stuff. I just love it. When I was in electronics, I was doing automated test, and I was using mixed signal. And mixed signal means we don't use a fucking scope, and we don't use a fucking spectrum analyzer. We used an AWG and an analog capture instrument, and the AWG and the analog capture instrument are clocked by the same clock, or by some integer relationship between those two. And that guarantees that when you do the FFT on the results, you get the signal you're looking for right smack in one bin. You don't get this spreading. People that use scopes, I call them scope dopes. And when I worked for Tektronix, oh God, I was immersed in scope dope land. It was horrible. People who use scopes and spectrum analyzers don't have a fucking clue how anything works, because everything they see is an estimation. The stuff that I did was incredibly accurate. When you send a signal from an AWG through the device and then capture it with an analog capture instrument, or if you send it from an AWG into like an analog to digital converter and then capture the digital, you get exactly dead nuts on what you're looking for. So when you're looking at harmonics, let's say your sine wave has 7 cycles, okay? 7's a prime number, even though you don't need a prime. I wrote an article on that. You don't need a prime number. 7 cycles. So, and you've got a ratio of 3 to 1 because you want your analog capture instrument to run slower by a factor of 3. That means 7 in, 21 out. You're going to capture 21 cycles of the wave, and it doesn't matter that they're not the same. It's fine. What happens is when you digitize 21 cycles and you do the FFT on that, you get your signal in bin 21. And then your second harmonic shows up in bin 42. And the third harmonic shows up in bin, what is that? Whatever that is. It just keeps going. It's all multiples of 21. Okay? And there's nothing in, if your second harmonic is in bin 42, there's nothing in bin 41, there's nothing in bin 43. Everything is in bin 42. Absolutely guaranteed. No doubt about it. And you can count on that. So that's the beauty of that stuff. When people look at the scopes and the spectrum analyzers, they get like some thing in some bin, and maybe it's bin whatever, but it's not all in the same bin, and so they have to do windowing, and I wrote an article on that. Windowing is, it's okay if you have to do it, but if you do things right, you don't have to do it. Look at the STS 3000, the Credence Duo Quartet, VistaVision, the Schlumberger EXA, the Teradyne A whatever. There's a bunch of testers, and the next test, Lightning. There's a bunch of testers out there, LTX, that actually do coherent sampling, and that's what the Apple Coast does. And I think that's what they're trying to do in the audio precision. But windowing is for morons. Don't use windowing. If you can totally avoid it, don't use it. Now, I want to talk a little bit about my book. I finally got some of these. Moron Harmonics for Morons. I love the title. I talk about that a little bit in the intro, where I talk about how you can use an FFT to make a Bullard plot. And a Bullard plot, I've talked about them before. this book is full of Bullard plots. In fact, the cover is made of a Bullard plot. So just by looking at the cover, you can see what a Bullard plot is. And it explains everything from that perspective. And you don't have to know anything about FFTs. You don't have to know anything about how the phases work. And the phases is a big deal, okay? I never, ever looked at phases. I knew that they were there, I mean, but you're almost always looking at the amplitudes. But when you're looking at harmonics, phases are important. And like I said in one of my videos, you can ask any dickhead with a degree, what are the phases of a distorted the harmonics for a distorted wave? They don't have a fucking clue. They don't have any idea. They couldn't even begin to guess. But Law 5, there's only 4 phases relative to a sine wave. If the fundamental is a sine wave, you got 0 degrees, 90 degrees, 180 degrees, or 270 degrees. That's it. There's no other choices. If there's any difference between those, you know what that is? That's hysteresis. So if your device has some hysteresis in it, let's say you're using an amplifier, you're testing an amplifier, if there's any difference between what you get and Bullard laws of harmonics number 5, 0 degrees, 90 degrees, 180 degrees, or 270 degrees, then you're looking at hysteresis. And you can measure the hysteresis from the differences between those numbers. That's really cool. That's a really cool thing. Now, in this book, I cover all 5 laws of the Bullard laws of harmonics. And it doesn't go into a lot of detail like distortion and harmonics do. And the reason is simple, because it's more on harmonics. Okay? If you want to know how I discovered all this stuff, you can read Distortion Harmonics. But if you want to know the basics, More Harmonics for Morons is perfect. And it's perfect for people. It's like a dummies book, okay? Except I can't steal the dummies name because they own that. So, More Harmonics for Morons. Check it out. $12.95 or whatever it is pretty cheap. Or if you do the Kindles, even cheaper. But I made it thin, I made it cheap, and it covers everything. So you don't have to like be a genius. You don't have to be a moron either, you know? If you're just interested in harmonics, this is the only place you're going to find the right information. Everybody else is full of crap. So check it out. And More Harmonics for Morons, Kindle or paperback. I like the paperback, but the Kindle's nice too. Anyway, that's it from the river. Thanks for your time. We'll see you later.